We're starting chapter 8 today. This is 8.1 ratios. First up here, the definition of a ratio is just the comparison of two numbers, okay? So I can look right here, I can compare right now Isabel and Michael. She's wearing a skirt, he's wearing pants. She's got a black sweater, he's got a blue sweater, okay? I just compared the appearance of two people. A ratio is simply comparing two numbers. There are three different ways that you can write a ratio. The first one, read me what it says.
A to B.
A to B. Now, if you were to look at this one right here, it's actually still said A to B. All right, it's got a little colon right there in between it, but it's still read a ratio A to B. Guess what the last one is read like?
A to B.
A to B. It's read the same exact way because it's a ratio. You're comparing things. You're comparing A to B. So out of all of those, when we are doing this, whether it's a test or a quiz or worksheet, when we're working in class with ratios, I would like us to always use this one right here. Just know, no matter what, this is read A to B, that's read A to B, this is read A to B, but once again, we're going to kind of focus on using the fraction part when we're comparing two separate things. The table here shows the wins and the losses of three different teams. Use the table to write the specified ratio for the Chicago Cubs. So let's just look at this. This is the baseball spring training. The San Diego Padres, how many wins did they have? 16. Let's look at the Dodgers. Did the Dodgers have more wins or more losses?
More wins.
They had more wins. Okay, they had 18 wins and only 13 losses. But today, what it has asked us, we're going to just kind of focus right here on the Chicago Cubs. So problem A says to write a ratio for the wins to losses. How many wins did they have? 17. And how many losses did they have? 14. Okay. Can that be reduced at all? What can go into a 17 that can also go into a 14? Nothing. Therefore, it cannot be reduced, okay? Now, when we look at this, we're not reading it as 17 fourteenths or 17 over 14. Do you guys remember how I said we would read a pair? 17 to 14 is how we would read that ratio. Very good job. Let's talk about the next one. Write a ratio for the wins to the games played. So now just as you're reading it, we are reading right here wins first, which means the wins will go on top. How many wins did the Cubs have?
37.
They had 17 wins. And how many games did they play?
31.
31. How'd you get that?
Because 17 plus 14 equals 13.
Okay, they had some wins, they had some losses. All you had to do was just add them together, and when you did that, you would get 31. Is there a number that can go into a 17 that also goes into a 31? No, there's not. So read to me this as a ratio. 17 to 31. So we've talked about we want all of our ratios to be as a fraction. So this one's asking us to write the ratio as a fraction in simplest form. If you look at problem A, it's already in a fraction, but is this in simplest form?
No.
What can go into a 9 that goes into a 15? A 3. So let's just go ahead and divide the top by 3 and the bottom by 3. If you do that, what do you get? 3/5. Problem B is read 6 to 5. Once again, we're going to put this as a fraction in simplest form. Jakari, if I put that as a fraction, what would it be? Very good. 6 over 5. Can that be reduced? No, there is nothing that goes into a 6 that also goes into a 5. Let's do one more sample problem like this. Problem C, 30 to 48. Alex, how do I make that look like a fraction?
30 over 48.
30 over 48. Landon, is there anything that can go into a 30 that can also go into a 48? All right, he says a 3. Thirty divided by 3 is 10, is 16. Okay. Is there anything else that can go into a 10 that can also go into a 16?
5.
A f-
No, 5, sorry, no. 2. 2, sorry.
A 2. So we're going to divide the top and the bottom by 2. What do we get? 5/8. Is there anything that can go into a 5 that can also go into an 8? No. All right. So really, if we divided by 3 and we divided by 2, what is 3 times 2? 6. So really, I could have put this right here divided by 6. However, it does not matter to me how you get to your answer. Okay? So no matter what, yes, that is in simplest form. The answer is 5/8. Another example of something you'll find on your homework tonight. Number 3 asks us, which ratio is not equivalent to 14 to 14? How would I write 14 to 14 as a fraction?
14 over 4.
14 over 4. Is that in simplest form? No. What can go into it?
2.
A 2. When I divide by 2 on top and bottom, what do I get?
7 over 2.
7 over 2 or 7 to 2. Is that in simplest form?
Yes.
Okay, so now we're just going to put everything else into simplest form and see if it looks like that. Let's look at this first example right here. 2 to 7. How would I write that as a fraction? 2 over 7. Let's look at the next one. How do I write this as a fraction? 14 over 4. Is that simplest form? No. What would simplest form be? 7 over 2 is the same thing. Okay, next up, how do I write this as a fraction? 7 over 2. And how do I write this as a fraction?
28 over 8.
28 over 8. Is there something that can go into both of those numbers? A 4. Okay, so I'm going to divide by 4 on top and on bottom. What do I get? 7 over 2. So now, going back to my original question, which one is not equivalent to 14 to 4?
A.
Problem A. How come?
Because 2 7s and
Because it says 2 to 7 instead of 7 to 2. Okay, so for that one, you're just kind of trying to figure out which one is not equivalent or doesn't equal the same thing. This table shows the number of boys and girls in middle school that attended youth group last week. Use the table to write the specified ratio. So we've got some different information here about the 6th, 7th, and 8th grade boys and girls that went to youth group. First up, 6th grade boys to 7th grade boys. Let's figure out what the ratio was of 6th to 7th grade boys that went to youth group. What would the ratio be?
19 to 25.
All right, listen. Let's look at the first part. 6th grade boys. What is that?
5. It's 15.
Look, 6th grade boys is 5 of them. Okay, so that's what you're going to put on the top. Next up, 7th grade boys. What would that be?
5 to 14.
14. So what should my ratio say?
5 to 14.
5 to 14. Can that be simplified?
No.
No. All right, so we had more from what, 6th or 7th grade?
7.
7th grade, very good. Now I want you to look at problem B. Don't say it out loud yet, but I want you to see if you can figure out the 7th grade girls to the 8th grade girls ratio. What is it, guys?
15 over 9.
15 to 9, okay? Because remember, you don't want to say 15 over 9, 15 to 9. Can this be simplified at all?
Yes.
What goes into both of them?
3.
3. If you simplify this answer, what would you get?
5 over 3.
5 to 3, all right? So the ratio was 5 to 3. More 7th grade girls came than 8th grade girls.
Oh man, I forgot my book.
Tonight's homework is 10 questions, which will look very similar to the problems we just went over.